Okay, ji, Bismillahirrahmanirrahim. So we were on to the Z transform portion, chapter 3. We saw that Fourier transform in some of the cases for few signals does not give you results. So to cover the larger classes of signals, we introduced the Z transform. और Z transform का जो difference है वो ये है कि इसमें एक factor R introduce होता है इसके constant के अंदर, Z के अंदर. Z equals to R E J omega के अंदर जो R का factor है वो बहुत सारे ऐसे signals के लिए ट्रांसफॉर्म निकालना पॉसिबल कर देता है जो कि फोरियर ट्रांसफॉर्म के लिए फिट नहीं है. ठीक है. सो कीपिंग दैट थिंग इन माइंड, एक और चीज जो इंपॉर्टेंट है वो ये कि फोरियर ट्रांसफॉर्म कन्वर्जेस ओनली फॉर दी स्टेबल सिस्टम्स. इफ सिस्टम्स आर स्टेबल तो फोरियर ट्रांसफॉर्म एग्जिस्ट करता है, बिकॉज वी डिफाइन दैट दिस समेशन n गोइंग फ्रॉम माइनस इन्फिनिटी टू पॉजिटिव इन्फिनिटी x ऑफ n e पावर x of e j omega. To compute this, we are not concerned with the power of e, because if we take the modulus, that goes to 1, right? So if this thing is less than infinity, only then this thing would exist. और ये less than infinity उस वक्त होगा once this is stable. So if the sequence is stable, और initially हमने chapter में introduce किया था कि x of n जिस तरह से एक stable sequence है, h of n भी लिया जा सकता है एक signal जो कि अगर लेस देन इन्फिनिटी है इसका समेशन. सो वी कॉल सच अ सिस्टम एज स्टेबल सिस्टम फॉर विच द इम्पल्स रिस्पॉन्स इज समेबल, राइट. सो फोरियर ट्रांसफॉर्म एग्जिस्ट ओनली फॉर द स्टेबल सीक्वेंसेस, बट जी ट्रांसफॉर्म एग्जिस्ट फॉर द नॉन स्टेबल सीक्वेंसेस. ठीक है. वी टेक एन एग्जांपल लाइक 2n un is an unstable sequence which is whose sum is not possible, which is exponentially growing sequence, but still its Z transform can be found. ये हमने सारा कवर कर लिया था. We saw one of the example. This example of x of n equals to a and un is an example of a right hand sequence which is which may grow or may reduce depending upon the value of a. For both the cases the Z transform will exist, and this will be called as a right hand sequence because a and un को right hand sequence हम क्यों कहते हैं? जीरो से लेके पॉजिटिव इन्फिनिटी भी होता है. It does not exist for the negative values, so this is a right hand sequence. Similarly, and we saw once we compute its Fourier transform, it comes out to be 1 upon 1 minus a z inverse with a condition that z modulus should be greater than a. So region of convergence is going away from the value of pole. ठीक है. The pole in this expression, once we write down x of z, it consists of number of poles and number of zeros. All the values of z for which this expression goes to 0 are called the zeros of the system, and all the values of z for which this expression goes to infinity are called the poles of this expression, right? So this is. And secondly, we can write down this z expression either in form of z inverse or in form of z. It depends upon our taste and ease of computation. So यहाँ पे without going into the details, I can just write down that z equivalent to a would be the one pole, right? And z equals to 0 would be the 0. If there is nothing in the numerator, once we are writing down in like this form of z inverse, it means that as I told you, another thing, that number of zeros of a system are always equal to number of poles, right? Vashne Qasim, is it possible that I have 2 zeros and 1 pole in the system, no second pole? You don't think so, or you're sure? You don't know. But just keep it in your mind that for any system the number of zeros are always equals to the number of poles. They are always equal. It depends whether zeros or poles, if they are not shown where they are. They could be at infinity or they could be at origin, right? Like in this case, this expression has got one pole at z equivalent to a. This is the pole, because this value makes this expression 1 minus 1 would be 0, 1 upon 0 is infinity, right? And it has got one 0 at z equivalent to 0, because यहाँ पे even if it is not visible, I can simplify this. The expression which I will get would be z upon z minus a. So this z equals to 0 makes this expression 0. So this is the 0 of the system. So there is 1 0 1 pole. But a number of other examples in which we will find out that there is no 0 visible, there is no pole visible. Like here it is visible 0 and, but for example if I write an expression like 1 plus z power minus 2 for example, right? Or to be more specific, like 1 upon 1 plus z, for example. If x of z is equivalent to this, then what you comment about its zero and pole? Where would be its pole? Pole कहाँ पे होगा इसका? z equivalent to -1. Where would be its zero? Maybe or sure? It should be at infinity, because the 0 equals to infinity makes this expression 0. So z at infinity is the 0 of this portion of this expression, right? Similarly, if I have got like this, x of z equivalent to z, for example, or 1 plus z, for example. In this case, where is the 0 of the system? 0 is at -1. Where is the pole? Pole is at infinity again, right? So this thing should be in mind, because your zeros and poles are always equal in a system, right? But you need to check it out by looking at the basic definition of zeros and poles, where they are, right? So we saw that this is a right hand sequence. We can get the expression for its z transform. Similarly, I showed you a negative or left hand sequence, which was, for example, a of minus a of n, u of minus n minus 1, because this indicates that you have flipped the sequence and you have shifted at -1. So it would be something starting from -1 and going to infinity. So such a sequence means starting from -1 going towards the negative side. So this sequence is called the left hand side sequence, or negative sequence. Again, the expression or the z transform for this thing is the similar one, like this one, 1 upon 1 minus az inverse. We solved it, but here the condition is different, that your z modulus or value of z should be lesser than a. These values of z which we compute for x of z to be valid are called the region of convergence, ROC, of this expression, right? Like in this case, the ROC is, if this is a, is going outward from the a. All the values of z which are lying in other than this place, because for this whole circle the z equals to a, okay? Because the z plane is a polar plane in which we represent the real axis and the imaginary axis. We can show it like something in terms of radius and the phase, right? So z equivalent to a means that I am having a radius of a and e power of 0, means 0 phase. So it is on the real axis, ठीक है? But this a radius would be around whole, ये इस पूरे सर्कल के अंदर हर जगह रेडियस की वैल्यू a ही होगी, right? Even on this side, even on this side, all would be a. So you always define the region of convergence from a circle, either it is coming inside or going outside. So in this case, z should be greater than a. Greater than a means you will not include that value of a, but the other values. बाकी सारी values include की जा सकती हैं जिनके लिए ये चीज converge करेगी, answer देगी. So this is the region of convergence, right? And this sequence is causal. Why it is causal? Because it is 0 for n less than 0. We defined causality definition कि वो सारे sequences जो कि n negative side पे exist ना करें उन्हें हम causal कहते हैं. तो ये causal sequence है, right? So इसको देख के भी बताया जा सकता है, ROC को देख के भी बताया जा सकता है कि इसका ROC चूंकि आउटवर्ड एक्सपेंड कर रहा है, तो ऐसे सारे सीक्वेंसेस कॉजल होते हैं जो आउटवर्ड जा रहे होते हैं फ्रॉम दी पोल लोकेशन, ठीक है, अंदर की तरफ नहीं आ रहे. जो सेकंड सीक्वेंस ये वाला, दिस वन द ROC इज इनवर्ड, Z शुड बी लेस देन A. तो अगर ये A है तो ये अंदर वाला सारा जो रीजन है, दिस वुड बी कॉल्ड एज द ROC, रीजन ऑफ कन्वर्जेंस. और ये नॉन कॉजल होगा बिकॉज दिस थिंग इज ऑन द नेगेटिव साइड, ठीक है. इससे यूज करके हमने ये डेफिनेशन निकाली है. वी केम टू दिस पॉइंट, और इसको देख के भी हम बता सकते हैं कि बिकॉज इट इज द इनवर्ट सीक्वेंस, द रीजन ऑफ कन्वर्जेंस इज इनवर्ट फ्रॉम द पोल लोकेशन, सो दिस वुड बी डेफिनेटली बी अ left hand side sequence which are non causal. So these systems are called non causal. ठीक. एक और चीज यहाँ पे हम deduce कर सकते हैं, that is about the stability of the system. Stability, in fact मैंने आपसे कहा था कि all those sequences which are for which we can compute the Fourier transform are called the stable sequences. So ROC को देख के भी हम ये चीज बता सकते हैं कि क्या इस सीक्वेंस का फोरियर ट्रांसफॉर्म निकल सकता है कि नहीं निकल सकता. if I just look at the ROC, and ROC includes the unit circle, because unit circle के ऊपर फोरियर ट्रांसफॉर्म डिफाइन होता है. ये अगर यूनिट सर्कल है, R = 1 है यहाँ पे, तो इस ROC के अंदर ये चीज कवर्ड नहीं है. अगर मैं इसकी एक्सप्रेशन लिखना चाहूँ इस पर्टिकुलर सिनेरियो में जो ये डायग्राम प्लॉट हुई है, इफ आई वांट टू राइट डाउन इट्स टाइम डोमेन फंक्शन, कैन आई राइट डाउन, इफ दिस इज 2, दिस लोकेशन इज एट 2, so can I write down the time domain representation of this signal? लिख सकता हूँ. I can write down कि x of n from where we started off was something like this, 2 power n un, because it's 1 upon 1 minus 2 z inverse. It means z should be greater than 2. तो ये जो ROC है greater than 2 वाला शो कर रहा है शेडेड रीजन जो है, राइट. सो फ्रॉम हेयर दिस थिंग कैन बी ऑब्टेन्ड, एंड फ्रॉम हेयर आई कैन ऑब्टेन दिस थिंग कि बेसिकली ये सीक्वेंस था जिससे मैं शुरू हुआ था. तो ये जो सीक्वेंस है इसका फोरियर ट्रांसफॉर्म नहीं निकल सकता, बिकॉज दिस इज अनस्टेबल सीक्वेंस, राइट. एंड बाय लुकिंग एट द ROC आई कैन टेल दिस, बिकॉज ये जो ROC है इसमें ये R = 1 इंक्लूडेड नहीं है. इट मीन्स के सीक्वेंस का फोरियर ट्रांसफॉर्म नहीं निकल सकता. तो ये सीक्वेंस स्टेबल नहीं है. दिस इज नॉट अ स्टेबल सीक्वेंस बाय लुकिंग एट द ROC. जी, अगर आपका R = 1 वाला यूनिट सर्कल इज इंक्लूडेड और पार्ट ऑफ द ROC, then the sequence is stable as well, right. And if it is going outward from the pole location, then it is a causal sequence as well. So this sequence is although causal but is unstable, right. Agar if would have been, this ROC would have been something like this, the pole location would have been here at point 8 for example. So इस case में ROC was this one, the whole thing away from the location point 8. So in such case this sequence was stable as well as causal, because it included the unit circle as well. अगर 1 के ऊपर आ जाता है तब भी डेफिनेटली, क्योंकि 1 के ऊपर है ना वो 1 of n, इनफैक्ट उस सूरत में वो स्टेबल नहीं होगा. रीजन बीइंग क्योंकि 1 से कम होना चाहिए वैल्यू. 1 वाली वैल्यू जो वो तो ऐड करते करते यू कैन नॉट सम इट अप, इट कैन गो टू इन्फिनिटी स्टिल. सो 1 से जब तक कम है it is in fact, because we can compute the x of n for 1, x of in fact e j omega, जो फोरियर ट्रांसफॉर्म है that can be computed for 1, right. 1 का फोरियर ट्रांसफॉर्म निकाल सकते हैं हम, right. So we can compute, although 1 is, अगर मैं इसका सम अप करना चाहूँ, summation n going from -infinity to infinity of 1, then it will go to infinity, because 1 plus 1 plus 1 till infinity cannot be a converging sequence, right. So in this way, in fact let me move forward. So we saw the definitions of Z transform, inverse Z transform, then this was the left hand side sequence which we solved. ये भी मैंने इसके ऊपर आपको बताया भी है, but this is how we solved it. So again the answer is same but with some different ROC. Here the region of convergence is inward from the pole location. Then we saw that there is a relationship between the Z transform and DTFE, discrete time Fourier transform, because Z equals to R e j omega. Once R is 1, then whatever Z expression we have got, that will be converted to a Fourier transform. जो भी आपके पास अगर if I just plug in Z equivalent to e j omega, then I can convert the x of Z into x of e j omega, which is the Fourier transform. In fact Z की जगह रख दिया ना, तो this is a Fourier transform. So अगर हमने x of Z निकाल लिया है, सिर्फ Z की जगह ये वैल्यू प्लग इन कर दें, we can get the Fourier transform. Z is basically a complex plane. We represent in a polar coordinates. Z is generally written like R e j omega. Z की जो definition है वो ये है R e j omega. So this R is the radius and omega is the phase or the angle which a point gets. So if I want to define this point, for example, which is at omega equals to pi by 4, says R value is equivalent to 0.8. तो मैं अगर इसको लिखना चाहूँ, इसकी रिप्रेजेंटेशन दे सकते चीज होगा 0.8 e j पाई बाय 4, ठीक है, यही होगा ना, एवरीबॉडी एग्रीड। और से अगर मैं एक पॉइंट लिखता हूँ z इक्वल टू -0.8 e पावर j minus j pi by 4, where should it be plotted? In fact, this is always positive, so it is wrong to write down in plus or minus, because this is the magnitude, so it should always be in positive quantity. So 0.8 would be the answer, but how would it be plotted now? Where should it go on this z plane? This is a negative angle of minus pi by 4, so it would be, अगर ये pi by 4 है तो it would be exactly the same one, say this one. So this would be the point, z equivalent to 0.8 e power minus j pi by 4. अब मैं कहता हूँ जी कि z equivalent to minus 0.8 प्लॉट करना है, कहाँ प्लॉट करूँ? नहीं, अब ये एक्सेस, ये ओरिजिन है ना, तो मैग्नीट्यूड तो डेफिनेटली है, लेकिन जब हम थीटा के टर्म्स में शो करते हैं तब तो इसको पॉजिटिव है कि मैग्नीट्यूड होना चाहिए, लेकिन अगर थीटा नहीं है इसका मतलब है कि थीटा कुछ है इसके साथ, वो थीटा क्या है? वो j पाई है, ओनली देन इट इज। अगर मैं ये नहीं शो करता, ये पाई शो नहीं करता अगर, तो आई कैन राइट डाउन एट -0.8, बिकॉज -0.8 जो माइनस साइन आया है दैट इज बिकॉज ऑफ दिस एंगल, यू हैव टू कवर दिस एंगल, कम हियर एंड ऑफ z इक्वल टू 0.8 e power j pi. This point is z equivalent to 0.8 e power j0. If I am writing down in terms of the phasors, I do not need to write it in terms of plus minus. The magnitude remains magnitude, right? But if I want, I'm not writing in terms of the phasor, then I have to give the plus or negative sign where it is. In fact, either it will be on the real axis or it will be on the imaginary axis or in between these two. मैजिक में कहीं भी हो सकता है ना, तो मैजिक में इजी प्लॉटिंग तरीका तो यही है कि आप इस एंगल और इसी में से प्लॉट करें, या एक और तरीका ये हो सकता है कि आप इसको x प्लस आयोटा y की फॉर्म में खोल लें और फिर प्लॉट करें, देखें कि x पे किधर जाना है, y पे किधर जाना है. दैट विल बी अ डिफिकल्ट थिंग. Easier way is to have this expression for all the other points and on to the real line. Once we have a real line, on real line we need not to see the angle. We can just draw that point looking at the magnitude and its sign. On the right hand side all the magnitudes are positive, on the left hand side all the magnitudes are negative, right? So say अगर मुझे कहते मैं आपको कहता हूँ कि z is equivalent to 0.8 e power j pi by 2 प्लॉट करना है, तो कहाँ पे पॉइंट होगा ये? अब इसमें माइनस प्लस देखने की जरूरत नहीं है ना मेरे भाई, तो ये 0.8 आप देखेंगे 0.8 सर्कल के ऊपर है, अब आपने देखना है इस एंगल को, एंगल कहाँ पे है? प्लस, तो यहाँ से एंगल ट्रेवल करेंगे तो ये पॉइंट होगा. सो वी रिप्रेजेंट एंगल्स इन टर्म्स ऑफ द पाइज. पाई इज इक्वल टू 180 डिग्री, 2 पाई इज इक्वल टू 360 डिग्री, पाई बाय 2 इज 90 डिग्री, पाई बाय 4 इज 45 डिग्री, पाई बाय 6 इज 30 डिग्री, पाई बाय 3 इज 60 डिग्री. ये जो बड़े बड़े मोटे मोटे जाविये हैं वो याद होने चाहिए, ठीक है? नॉट टू आखिरी वक्त आप लिख के उसको याद कर रहे हो, राइट? सो वी कैन ऑलवेज रिप्रेजेंट the zeros and poles. Now these are all the poles which I am showing. I can also show the zero as well. I can show my zero location z is equivalent to at 0.8 e power minus j pi by 2, my location of 0. So when I need to plot it, where would it be plotted? I think क्या confirm होना चाहिए आपको, ये j minus pi by 2 means you will start from here and cover a negative angle of, so this would be the point. Now this is not a pole, this is a zero, so you will represent a zero like this. So in this way we can draw and we can retrieve the information if something is drawn. Okay, where is the zero and pole? I am not calling it specifically a zero. I started from this point that I am not going to draw a zero. So a zero pole could be at any place on z plane, not necessarily at any specific point, can be anywhere. Fourier transform in terms of the z, in where we represent, or we in fact I told you that our x of e j omega, or the Fourier transform, is called the discrete time Fourier transform. This is called discrete time Fourier transform, right? Because once you draw it, it is continuous on the omega axis. Small omega going from minus pi to positive pi, maybe you'll just draw the complex spectrum, continuous spectrum, right? This is depending upon omega, and omega cover all the values from minus pi to pi. But if I discretize this axis and I define omega to be only at 2 pi k over n, and I define n to be some points, say my n is equivalent to 16 points. So if n is 16 points, this means I am taking 16 points in between this periodic interval of minus pi to pi, right? And k would vary from 0 to n minus 1, means 15. So you just vary the value of k, keep n constant, and get the values of omega, for which you define the x of e j omega. And those would be called, in that case it would be called x of k. And x of k is now called the discrete Fourier transform. It's not the discrete time Fourier transform. Here we have discretized the Fourier domain representation. हमने इसको ही discretize कर दिया यहाँ पे. अब उस जगह पे you may got a value like this, 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 and nothing in between, right? So such a spectrum is called discrete Fourier transform. This is something which people remains confused throughout their life. Okay, what is the difference between DTFT and DFT, right? So keep this thing clear in your mind, because this will you be looking at number of places, number of papers, research papers में हर जगह आप देखेंगे तो DTFT और DFT का minute difference है जो आके आपके दिमाग में clear होना चाहिए, right? So we can always get the discrete Fourier transform from the discrete time Fourier transform. So this अगर आप उसको plot करेंगे तो discrete time Fourier transform जो है that is plotted on the entire circle, but discrete Fourier transform will be only defined at the points of some omega. Like here, the number of omega or the n is equivalent to 8, because only 8 values of omega are defined on the circle. Z transform properties, like just like in the Fourier transform, the del of n, if I take the Z transform, I get an answer of 1. DTFT stands from discrete time Fourier transform. So usual हम compute करते रहे x e j omega, that was DTFT, discrete time Fourier transform. अगर इसको मैं compute करूँ तो this is onto the unit circle of Z plane. तो ये पूरा का पूरा जो circle है इसके ऊपर जो भी values आ रही हैं x of e j omega, all called the x of e j omega or DTFT. But once I discretize the values of omega, because ये जो points हैं सारे के सारे, इन सब पे कुछ omega की value है. Omega is in fact the phase in the Z plane, because ये point जो है it has got an r, and e j omega means this has got this theta is equivalent to omega Z plane. So ये ओमेगा जो है अगर 0 भी हो सकता है, 0.1 भी हो सकता है, 0.001 भी हो सकता है, 0.2 भी हो सकता है, 0.3 भी हो सकता है. If you continue like this for all the omegas, then the resultant transform is DTFT. But once I discretize omega to be equivalent to 2 pi k over n, and I define the n to be some fixed number, like in this case n is equivalent to 1, 2, 3, 4, 5, 6, 7, 8. n is 8 point DFT. In this case it would be called E8 point DFT. It means 8 values of x e j omega only, right? And it will be represented like x of k. Here the z would be not e j omega, but e j omega value would be replaced as 2 pi k over n. So जो value आपके पास जैसे n 8 है, तो omega is equivalent to 2 pi k over n, and k goes from 0 to n minus 1, 7, right? So first omega or omega naught would be equivalent to 2 pi multiplied by 0 divided by n would be 0. So here at this point omega is 0. Second omega 1 would be equivalent to 2 pi k is 1 divided by n is 8. So once I cancel it out, the answer is pi by 4. So this point is pi by 4, 45 degree के ऊपर है ये. Then if I come out with the third value of omega, adds omega 2, which would be 2 pi, k is 2 now, divided by n is 8. So 2 and 2 cancels, and here I get an answer of 2. So it is pi by 2. So this point is at pi by 2. In a similar way, all these points have been defined, but these are the distinct points of Fourier transform. So such a transform is called discrete Fourier transform, not discrete time Fourier transform. Discrete time Fourier transform is a term used to represent the Fourier transform of the discrete sequences. जिधर से हम ये इधर आए थे, हम आए थे x of n से, ये मालूम किया था हमने. अब इसको डिस्क्रिटाइज अगर कर देंगे तो इधर आ जाएंगे हम. ये DFT है, अब ये DTFT था. Okay, now some of the very common Z transform properties, like we saw that del of n has got a Fourier transform of, अगर इसका Fourier लेते थे, that came out to be 1. Similarly, del of n minus n naught, its Fourier transform was e power minus j omega n naught, right? So in the similar way, the del of n has got a Z transform of 1, and del of n minus n naught has got a Z transform of z power minus n naught. राइट अगर इधर प्लस है तो इधर प्लस हो जाएगा. So these are the some of the form of famous Z transforms. There are few others which I'll show you, but if this is a finite length sequence, I can easily get its Fourier as well as its Z transform by just looking at this. This would be Z of plus 1 plus 2 minus Z of minus 1 plus of Z minus 2. So this is written over here. I can compute it by plugging inside the expression. That takes some more time, so I can just write down like this. Right, so this is true for all Z. अब यहाँ पे जो आपके पास Z transform है, in fact अगर हम इसमें गौर करें, so it is in fact covers all the Z plane. इसका region of convergence, because definitely once I have computed the Z transform, I have to write down some of the ROC as well. But this particular scenario for the finite length sequences, the Z transform has got the whole Z plane as the ROC. And we'll see that because it may cover may not cover some of the poles at the infinity or some of the zeros at somewhere, but that will be defined but once I go into the properties. But for the time being, this covers the entire Z plane. So this we covered already. This is the right hand sequence. AN, UN, I can get the answer 1 upon 1 minus AZ inverse with a pole at A. Now if this A is below 1 or less than 1, then my ROC would be the whole green circle, whole this green area. Okay, going out from A, from the radius of or circle of radius A, and it covers the unit circle at 1. So this sequence is stable if A is less than 1, and it is causal because it is a right hand sequence. The ROC is going outward from the value of pole, right? This sequence A and UN has got a 0 as well, and that 0 at Z equals to 0, but 0 does not play any role in the ROC. The ROC is determined by the poles only. It has a 0 at origin, but that does not play any role into the definition of ROC because that does not affect anything. We define the region of convergence. Region of convergence का मतलब ये होता है कि जहाँ पे Z transform exist करता है, तो poles के ऊपर Z transform exist नहीं करता, इसलिए poles important होते हैं to define the ROC. Pole is something for which Z transform goes to infinity. It means it is not defined, undefined. So we are definitely, naturally we are concerned about the poles, not about the zeros. Okay, now coming on to the sum of two exponential sequences. This is something a little different. If I have got a sequence like this one and a sequence like this one, both of them are the right hand side sequences. I can simply say from here, I can use the usual mathematical expression, write it down inside and then compute it, but I can directly write it down as well, because this would give me an answer of 1 upon 1 minus 1 by 2 Z inverse, plus this would give me 1 upon 1 minus would be 1 upon 3 Z inverse, right? So I can further solve it out to get the values of zeros and poles of the whole system, because at this moment I do not know what all are the system's zeros and poles. It is composed of two signals which have been added together. So I can take the LCM for both the systems, right? And if I do that, I'll get an answer of 1 upon 1 minus 2 Z inverse into 1 upon 1 plus 3 Z inverse. यहाँ पे it would be something like 2Z into Z minus 1 minus 1 by 12 Z inverse. इसको solve करके आप देखेंगे तो इस तरह की एक चीज़ निकलेगी. So by looking at this now I can define the zeros and poles of the system. This is the whole system, or the two signal composed of two signals. So for the total signal I need to get the total expression, and total expression, in fact all those values of Z for which this whole expression goes to 0 gives me the zeros of system, and the values of Z for which this expression goes to infinity gives me the poles of the system. So it has got two poles. One pole is at 1 by 2 and another pole is at minus 1 by 3. So if I draw it, this is a general representation or drawing way for drawing the poles and zeros. This circle shows a unity circle. Even if you write it or do not write it, it is understood that ये unit circle plot किया हुआ आपने, right? So अगर मैं इसमें zeros और poles plot करना चाहूँ, तो this 1 by 2 is equivalent to 0.5. So it is a positive at a positive real side. So it would be somewhere here, and this is at minus 1 by 3. ठीक है? So it would be somewhere here. These are the two poles locations, and there are two zeros. One zero is at Z equivalent to 0, and second zero is at equivalent to 1 by 12. So it would be just adjacent to that. These are the two poles and two zeros of the system. What would be the ROC of the system? Region of convergence जो है वो इस पूरे सिस्टम के लिए होगा ना, पूरे सिस्टम्स को देखना आपने कि वो कौन सी वैल्यूज ऑफ z हैं जिसके लिए ये एग्जिस्ट करता है. We need to see that value of or those values of z for which this expression exists, does not go to infinity, right? So if I just take the first signal, for example this one, so this one has got a value of 1 by 2. It means if I define a circle at 1 by 2, so my ROC should be away from this as far as my earlier understanding is concerned. Lekin I have got another system as well, a plus with this, so it means this there can be a circle here as well, and iska bhi ROC se outward hona chahiye, right? So the overall system's ROC is the one which is the region of overlap, the region of overlap which is covered by both. So वो जो both से cover हो रहा है वो ये वाला area cover हो रहा है and going outward, leaving the internal portion. This is not part of ROC. ROC is the region of overlap of both the poles. So as these, अगर इससे हम थोड़ा सा कंक्लूजन निकालें, ये दोनों जो इसमें सिग्नल्स थे दोनों के दोनों राइट हैंड साइड सीक्वेंसेस थे. तो एक का जो पोल था वो भी आउटवर्ड था, उसका ROC भी आउटवर्ड था, इंडिविजुअल देखते, और इसका भी ROC जो था वो आउटवर्ड था. ठीक है, both of the systems had the ROCs going away from the pole, right? And overall system, which is combination of these two signals, has got an ROC which is the region of overlap of both the systems, which is in fact the region of convergence of the larger pole or the outward pole. 1 by 2 से जो आउटवर्ड जा रहा है उसका जो रीजन है वो पहले वाले से भी कवर हो रहा है, दोनों में कवर हो रहा है, right? So we can say that the region of convergence for the right hand side sequences is the area away from the outward pole or outmost pole. ठीक है, अगर एक तीसरा पोल भी होता, say a third signal would have been 0.8 power n u of n, so it means there is a pole at 0.8 as well somewhere here. So in that case the region of convergence would have been away from this pole, because that pole or that region of convergence covers the region of convergences of the first one and the second one. सबके अंदर वो cover होता है, right? And this is understandable because देखो अगर इसके अंदर मैं z की वो values अगर मैं इसे 1 by 3 से आउटवर्ड लेता, अगर मैं इसका रीजन ऑफ कन्वर्जेंस इससे ले लेता 1 by 3 से आउटवर्ड ले लेता, तो 1 by 2 भी उसमें आ जाता. तो 1 by 2 जब इसमें प्लग इन करता मैं तो ये इन्फिनिट कर देता इसको. सो ROC हैज टू बी द रीजन फॉर विच दिस एक्सप्रेशन शुड एग्जिस्ट, और वो एग्जिस्ट उस वक्त करेगी जब तक z जो है, जब z सबसे बड़े पोल से भी बड़ा होगा. ठीक है, यानी आई कैन राइट डाउन दैट माई z शुड बी ग्रेटर देन 1 by 2, और आई कैन से इट एज अ मॉडुलर वैल्यू 1 by 2 बिकॉज दिस इज अ circle. So this is solved over here, we can just check it out. So the ROC in fact is the region of overlap. इसके अंदर यही डायग्राम दिखाई गई है, 1 by 3 का 1 by 2 का अलग अलग दिखाया है, उसके बाद दोनों का कंबाइंड दिखाया है. तो ROC जो है वो रीजन ऑफ ओवरलैप है, ओवरलैप जो है 1 by 2 से आउटवर्ड होता है, 1 by 3 वाला जो है वो ओवरलैप नहीं होता. आई होप यू अंडरस्टैंड व्हाट आई मीन बाय ओवरलैपिंग. दोबारा बताओ कहाँ पे. ये मेरे पास एक सिग्नल था 1 by 2, ये है, ये जो प्लॉट हुआ हुआ है दिस इज फॉर 1 by 2 n un, और ये प्लॉट हुआ हुआ है -1 by 3 n un के लिए, और ये प्लॉट हुआ हुआ है दोनों के समेशन के लिए. कोई फर्क नहीं पड़ता, वो तो पोल की लोकेशंस है ना, बट एक्चुअल इज you have to see because this z is nothing but z's definition by definition is r e j omega. So whatever the value of z is, that is in fact the radius. It will be in the whole circle. Actual location ये है, लेकिन इससे एक सर्कल डिफाइन किया जा सकता है, बिकॉज जब हम उसकी डेफिनेशन निकालते हैं तो वी कंप्यूट दी मॉडुलस वैल्यू. दिस हमने देखा, इसको हम जब कंप्यूट किया था 1/1 माइनस AZ इनवर्स, तो हमने इस पूरी चीज को लिया था कि AZ इनवर्स का जो मॉडुलस है दैट शुड बी लेस देन 1, ओनली देन दिस एग्जिस्ट बिकॉज इट्स समेशन ऑफ ज्योमेट्रिक सीरीज. और उसको जब सॉल्व करते हैं तो मॉडुल ऑफ Z कम्स आउट टू बी ग्रेटर देन मॉडुलस ऑफ A. तो वो बेसिकली क्योंकि ये एक स्केलर वैल्यू है एंड Z इन फैक्ट इज अ फेजर, इज अ कॉम्प्लेक्स नंबर, तो जब ये एक सिंगुलर वैल्यू आएगी तो इसका मतलब ये है कि उसके अंदर ये पूरी की पूरी चीज कवर हो रही है फॉर होल ओमेगा. ये जो एक सिंगल नंबर होता है वो एक रेडियस को शो कर रहा है. ठीक है, तो जो उसकी स्केलर क्वांटिटी वैल्यू, बिकॉज मैग्नीट्यूड अगर इसके मैं साथ e पावर j पाई बाय 2 भी रख दूंगा तो उसका मैग्नीट्यूड गोज डाउन टू 1. ठीक है, तो अल्टीमेटली चीज ये बच जाती है. तो अगर मैं ये कहता हूं कि मॉडुलस ऑफ z इज ग्रेटर देन सम मॉडुलस a, इट मींस दिस इज द होल एट ऑल पॉइंट्स इन द सर्कल, not only at one side, on the right hand side or left hand side, ये एक सर्कल डिफाइन होता है हमेशा, दिस इज बाय वर्च्यू ऑफ डेफिनेशन ऑफ जी ट्रांसफॉर्म। तो यहाँ पे ये ऑल्दो ये पोल लोकेशन है उसकी -1/3 पे, ये 1/2 पे, ये दो जीरोज हैं, लेकिन एक सर्कल इधर बन सकता है, एक सर्कल इधर बन सकता है, और ROC जो है दैट इज फ्रॉम दी रीजन ऑफ ओवरलैप ऑफ बोथ दी सर्कल्स। तो जो इसका सर्कल था वो भी इसमें, उसमें भी ये रीजन कवर हो रहा है, और जो ये इसका सर्कल है उसमें तो वो रीजन है ही, ठीक है। तो जो ये इतना जो पोर्शन बचा था ये वाला, ये ओवरलैप नहीं हो रहा, ठीक है। तो वी कैन अवॉइड दिस। ओवरऑल ROC इज ओनली दिस वन which is going away from the outermost pole in case of the right hand side sequences. Okay, now this is another example. This is an example of two-sided sequences. Now I am having a right hand side sequence -1/3 and un. It would be, once I take the z transform, I get this expression 1/1 plus 1/3 z inverse. It means it has got a 0 at 0 and a pole at -1/3. Right? Okay. See the second sequence. -1/2 and u minus and -1. This is a left hand side sequence. Right? Again, once I compute its Fourier transform, it gives me this answer. 1 minus 1/2 z inverse. It has got a pole at 1/2. If I draw now, so this is my 1/2 पे ना पोल इसका, और इसका जो पोल है वो 1/3 के ऊपर है, -1/3 के ऊपर है, राइट। सो रेडियस अगर मैं इसका सर्कल ड्रॉ करूं तो दिस वुड बी द फर्स्ट सर्कल, दिस वुड बी द सेकंड सर्कल, राइट। बाय द डेफिनेशन ऑफ ROC, दिस इज अ राइट हैंड साइड सीक्वेंस, सो इट्स ROC शुड गो अवे फ्रॉम द पोल लोकेशन। इसका पोल किधर है? 1/3 पे, ये वाला, इससे आउटवर्ड जाएंगे आप। दिस वुड बी द ROC फॉर द फर्स्ट सीक्वेंस। सेकंड सीक्वेंस हैज गॉट अ पोल एट 1/2. So 1/2 is here, and this is a left hand side sequence, so its ROC would come inward from the pole, so it would be inward, this whole thing, right? So what is the region of overlap? ये जो अंदर वाली चीज है ये पहले वाले में नहीं आ रही, और जो आउट वाली चीज है वो दूसरे वाले में नहीं आ रही। So जो ये डिस्क बन गई है या जो रिंग बच गया है, this is your ROC. इसके अंदर जो भी जी की वैल्यूज होंगी वो इस एक्सप्रेशन को इन्फिनिट नहीं होने देंगी। आई रिपीट, ये जो ROC के अंदर जो भी जी की वैल्यूज होती हैं वो इस एक्सप्रेशन को, ओवरऑल एक्सप्रेशन को इन्फिनिट नहीं होने देती, इसलिए उसको ROC कहते हैं। उनके लिए एग्जिस्ट करता है, और यू कैन चेक इट आउट। जब इसमें आप 1/2 प्लग इन करते हैं तो ये इन्फिनिट हो जाएगा, जब इसमें आप 1/3 प्लग इन करेंगे ये इन्फिनिट हो जाएगा, राइट। सो वी नीड टू बी विद इन दिस रेंज ऑफ जी in this ring. So for this ring values of z, this expression would give you an answer. So these are some of the common z transforms. Del of n is 1, u of n is 1/1 minus z, minus u, minus n minus 1 is 1/1 minus z. ये सारे के सारे आप, it's just from the book. You can just note them down. There are few others as well.
वीडियो खत्म करने से पहले आपसे दरख्वास्त है कि वीडियो को लाइक करें, कमेंट करें, चैनल को सब्सक्राइब करें और बेल आइकन को लाजमी प्रेस करें ताकि हमारे हर आने वाली वीडियो सबसे पहले आप तक पहुंचे।